with the Watercress company for the last 4 years or so. So a quick bit about them. They're based in the UK. They have about 60-70% of the UK's watercress market. They're the biggest independent producer of watercress in the world, largely out of Dorset and Hampshire in the UK. They've also got fields in Spain, which they need to use for the climate, because obviously in the winter you can't grow watercress here. And then they've also got farms in Florida. So they're making an awful lot of watercress throughout the year for us, about 2.5 million kilos worth. So I'm going to take you on a bit of a journey of the science that we've got to get us here now. We've recently set up Watercress Research Ltd. This is our team. One important person missing up there, Mark Bowes-Kavanagh. And so is myself, Paul, who's a professor of experimental medicine at Exeter, Roger, who was a software developer working in the NHS, and Nick Sprague, who's an entrepreneur from Exeter, who owns the company Cobell. So we had some funding from Torbay Medical Research Fund, and I'll mention them at the end. And we asked ourselves, how can we get these urease inhibitors out? And can we make a urease inhibiting liquid to maybe counteract this nappy rash effect and make a drink or some sort of food as a therapy? So we said to ourselves, well, we probably have to blend it up first. So we went to the Biorenewables Development Centre in York, and they blended up some watercress for us. And like any good scientist, we said, well, we obviously have to taste it. So we wonder what it tastes like. And then we realized that when we tasted it at different times, it tasted different, and we didn't know why, which then brought us into reading about isothiocyanate in cruciferous vegetables. So what we were noticing when we were tasting it is a difference in the pepperiness in the watercress. And from our reading, we found out this is driven by isothiocyanates. So what we were experiencing was a plant host defense mechanism. So normally in the plants, so in the cruciferous vegetables, you've got something in the cells called glucosinolates. When you mechanically disrupt the cells, that mixes with an enzyme called a myrosinase and makes this group of chemicals called isothiocyanates. This mechanical disruption is a plant host defense mechanism. The reason it's pepperiness in watercress is to try and make us stop us eating it. It's a deterrent. And it also has some other stress hormone effects similar to steroids in humans. And what we found out is that actually lots of different vegetables in this cruciferous vegetable category upregulate different isothiocyanates. So arucins in rocket, allyl isothiocyanates in wasabi, benzyl isothiocyanate in mustard seed, phenethyl isothiocyanate is the predominant one in watercress, sulforaphane in broccoli, and moringin is found in the moringa plant. And I didn't know what that was, so I put a picture there, and apparently it's very tasty and also known as a bit of a superfood. So the isothiocyanate story is interesting. So while we're interested in the phenethyl isothiocyanate of watercress, there's quite a nice story with allyl isothiocyanate in wasabi. So these are the wasabi plants, and when you harvest them, you take this bit in the middle called the rhizome, which is the bit above the roots, and then you blend it down. Now, if you grate wasabi and taste it straight away, it doesn't taste very peppery. If you then taste it 5 minutes later, it is extremely peppery, very, very spicy. And then if you taste the same thing again, the pepperiness is gone because the allyl isothiocyanate is produced, and then the enzymes, other enzymes, then break it down. So it's only a temporary stress mechanism, which is why, interestingly, if you look at all the wasabi you get, they're not actually wasabi, they're mustard extract. They're not the allyl isothiocyanate from wasabi, they're the benzyl isothiocyanate from mustard seeds, because the allyl isothiocyanate is not stable enough. So we discovered that if we were to blend the watercress up, after 2 hours, we could maximally convert all the glucosinolates in watercress into this phenethyl isothiocyanate, or PEITC. And we started to realize that there was an awful lot of very interesting research going on around the role of phenethyl isothiocyanate in inflammation and cancer. So if I read a couple of these headlines: dietary phytochemical PEITC restricts tumor development via modulation of epigenetic writers and erasers, epigenetic reactivation of RAS F1A by phenethyl isothiocyanate, promotion of apoptosis, We keep going on. PEITC suppresses prostate cancer. Anti-tumor activity of PEITC in breast cancer. PEITC induces apoptosis in non-small cell lung cancer. So we found this absolutely fascinating. So this word epigenetics comes up, and it seems that PEITC has a role in regulating epigenetics. So what epigenetics is it's a balance between your environment and your genetics. So your genes are never going to change. And a lot of your features are seen due to your genetics. So for example, whether you're male or female and what your height are largely genetic. But you can have environmental factors which can then change your phenotype or what you look like outwardly. And these could be hormones that are produced by the body, or these could be outside external factors. A very good example of this is the bee. If you take a worker bee, if you take two worker bees, in fact, which are genetically identical, and you feed one of them royal honey, they will turn into a queen bee. Those two bees there are genetically identical. But in the one on the right, the royal jelly has triggered an epigenetic change to switch on the queen bee genes and switch off the worker bee genes. Exactly the same way as a caterpillar, or it can switch off its caterpillar genes and switch on its butterfly genes. So PEITC seems to have this very favorable, or so the literature would seem, role in switching off the cancer genes and switching off cancer survival genes and switching on cancer death genes. And one of the other reasons it can do this is it does have a very good role in regulating inflammation through mechanisms that we don't yet understand. So inflammation happens in lots of different conditions, from infection and injury, but it can also be linked to chronic diseases, your Alzheimer's and cardiovascular disease. And inflammation in itself is linked to cancer, because the more you have inflammation, the more you have cell turnover, and the more you have cell turnover, the more chance there is that one of these cells is going to make a mistake, which might not be picked up by the immune system. This can lead to cancer. So we became quite excited that we had this fantastic new way of producing something which is being actively studied in cancer as an adjunctive cancer therapy, and also as an anti-inflammatory. So what we are now actually looking at is whether we can interrogate the genome with our watercress extract to reveal epigenetic consequences, whether they are good or bad. So this is a little bit of a side bit on new ways that we can do science to avoid clinical trials. So we're hoping to work with these chaps at Quest Genetics. So what they're able to do is effectively lie the genes in a row, apply our extract, and see which ones light up. So effectively what they're looking at is seeing where you're getting epigenetic interactions. These might be good, in which give a favorable outcome. These might be bad, which means they're toxic. But what we're really hoping to do is use this platform and see whether our PEITC does indeed have the potential to regulate epigenetics in various cancer and disease states. We're then hoping to move on with a company called Biosystems Technology. So again, this is a little side thing. They use larvae. So we can hopefully see phenotypic changes in larvae, which are the direct result of the epigenetic regulation using the watercress extract. So that's all been very exciting. The PEITC from watercress and the sulforaphane from broccoli are now being researched in all these different clinical conditions that you see below you, which begs the question, well, can't I just eat watercress? Why do we need to extract it? Well, our graph says that you get a maximal PEITC concentration at 2 hours, which means you'd have to chew the stuff for 2 hours to get the maximum PEITC. And which then also leads us on to the question about, well, if wasabi and the allyl isothiocyanate degrades and loses its flavor, why won't watercress do the same? Well, the reason is watercress, after we blend it up, does this very interesting thing. When you heat it to 85 degrees, it curdles. And the reason it curdles is, unlike lots of other fruit and vegetables, it has an extremely high protein content. So half the calorific content of watercress is protein, which is about the same as a ribeye steak. The difference is there aren't that many calories in watercress to begin with, but when you heat it, those proteins come together and curdle. So you actually end up separating off all the protein. a lot of that protein is from enzymes. So you're denaturing the enzymes, which would otherwise then start degrading the phenethyl isothiocyanates into other species. This means that we've now got a PEITC extract, which is stable, and it is the first time in the world this has ever been done from a plant. And we've demonstrated stability after 3 months. So we became quite excited by this, as you can imagine. And then obviously our minds went back to thinking about urease inhibitors. Could it be that this mechanism and this surprising finding of curdling meant that our urease inhibitors were also in this liquid? And they are. So I'm not going to go through this table. This is some ultra high performance liquid chromatography, which is a very clever way of detecting molecules in liquids, which we had done at Rothamsted Research Centre and also at York Biorefinery as well. So we found that we've got flavonoid groups, tryptophan, vitamin C, and a few others, all of which are known urease inhibitors when we've referenced the literature. So,
hi, around the corner, please. Just thank you.
Oh, sorry, that's not me. Can someone mute their microphone? Whoever's getting a delivery. Thanks. So now we wanted to test our urease inhibitors. So we took jack bean urease. So there is a plant which actually makes a urease enzyme as opposed to the urease. This plant called the jack bean. And what we did is we set up some controls. So we took the enzyme at different concentrations across a big range. We put some urea in there, and we found that actually we can produce lots and lots of ammonia to above the upper limit of quantification, so way more than the sensor can pick up. So if you look at the next slide down, we then took undiluted watercress extract and we put it with different concentrations of urease, and we actually managed to, at low and medium levels, actually completely reduce to below the lower limit of quantification ammonia, which means we completely blocked the urease to not produce ammonia. And even when we put on very, very high levels of urease enzyme, we still had a significant inhibition, which means, good news, our watercress extract does indeed inhibit urease at a level which would be physiologically active, so would have an impact in the conditions that I mentioned at the start. So excellent news, we've now got a PEITC and urease inhibiting liquid. So of course, as all good scientists, Paul and I said to ourselves, well, should we drink it? And we didn't know, because we didn't know if it was going to be toxic. We didn't know what other changes had happened in it. So we thought, well, if we start with the skin, then there's hopefully less regulations there. And if we can prove it's not irritant on the skin, then that might be a way for us to get into a nappy rash market, and then we can worry about food and drink down the line. So we started working with a company called LabSkin. So this is another fantastic company who are replacing the need to do clinical trials. So LabSkin have developed a validated in vitro skin model system where they grow real skin cells on a mesh which respond the same way to chemical irritants as skin does. It releases the same chemicals and it has reductions in cell viability in exactly the same way normal skin would. So we were excited until it didn't work. So our PEITC and urease inhibiting irritated the skin. See here is not very much interleukin-1 alpha. So this is IL-1 alpha is basically the cells released when they're irritated and when they're stressed and they're not very happy. Formula protease so pre-parabola on the right was pretty much the maximum inflammation on the skin it could in. Because we thought, well, what's causing that, but so we can't make a topical product out of something which is irritating the skin, until we realized that we had a contaminant, and it was a bacteria that had managed to survive at the 85-degree heating that had curdled the protein, and when it was cultured up still remained viable. And we've grown this up and we've had its DNA sequenced at York Biorenewable Centre again, and we've effectively discovered a brand new bacteria which has never before been seen in the UK and has been seen once before in Portugal. And we know it's this because the team in Portugal sequenced its DNA, and this is the only one that matches. And actually, where this bacteria was found in Portugal was alkaline spring water, very similar to where you grow watercress. So we now believe that this new bacteria, which I've had to scrub out because we're looking to move ahead and patent it, because it's got some, or patent its use for various things, because it has some interesting features. This microreason Watercress has urease inhibitors because it's in a symbiotic relationship with a bacteria, which it can switch on and switch off based on its surrounding conditions, just in the same way that in our gut, we've got a microbiome. And pretty much in every organ system that we've got bacteria that we control and that control us, and we live together, benefiting from each other quite happily. So from a plant science perspective, this has been quite a significant discovery. So that aside, we then realized, well, we're going to have to sterilize our extract because we can't have a bacteria inflaming the skin. And the thoughts from lab skin were this is going to be a direct bacterial inflammation. So we sterilized it. We sterilized it in 4 different ways. So a combination of centrifuging, which is spinning it down to 10,000 times gravity, autoclave 121 degrees, and also passing it through sort of biological remnants of anything which is in there. So we thought, we don't really know which way to sterilize it. We'll try all 4. And it worked fantastically well. So what this is, again, is the release of IL-1 alpha. So phosphate buffer is your control, and you can see extract A, B, D, and E all have cause the same release of IL-1 alpha as the phosphate buffer, suggesting it absolutely does nothing to irritate the skin. And you compare that to 5% SDS, which is your positive control, which caused a rise in the release of IL-1 about 40-fold. So the good news now is we haven't caused inflammation. But it gets a bit better than that, because the other thing they tested is mean cell viability. So what you expect is when you inoculate the skin with some sort of chemical or compound, the cell viability should drop. And what the cosmetic companies often want to strive for is to get a percentage viability which is approaching 100%, which again is just your bog standard phosphate buffer. So you want it to be 98, 99%, and you can say that is viable. On every one of our extracts, it overshot. So the skin was more viable after having our 4 extract applied. It was more healthy than the control. So this is a bit of an unexpected discovery, but then we thought to ourselves, well, actually, is it? Because if we do have something like PEITC, which is beneficial in regulating inflammation, is this actually a side effect of us having some very clever chemicals which are going to be useful for the skin? So the reason this is now becoming interesting is we started out looking at urease inhibition for nappy rash. Well, nappy rash in itself is an inflammatory reaction. And if we're demonstrating that, we've also got a separate separate anti-inflammatory mechanism, which is non-urease mediated, because in that previous slide, there's no urea. This means that we've got a dual effect. So for nappy rash, we can stop the production of ammonia, which makes the nappy rash. But if you've got nappy rash, we've also got a skin soothing capacity. So we're a little bit excited now, because we're hopefully going to be we're speaking soon to someone who makes sun cream, because if you get sunburn, that's UV radiation damage. Now, we know already that PEITC is going to be useful at regulating inflammation. It might also be useful at switching off some of these genes which might predispose us to developing skin cancers. So that's where we thought we were. But now also, because we know we've got this non-urease mediated anti-inflammatory action, could this be effective in conditions like eczema, psoriasis, other chemical dermatitis? Have we got a new treatment for eczema? In the same way that aloe vera has been very popular in recent years, the evidence that we've got now is actually that this watercress extract, by these 2 separate means, urease inhibition if it's mediated by urine, so more incontinence in nappy rash, but also PEITC, could be extremely useful. So we're now working with a company who are a formulation cosmetic company in Paynton called ADSL. And we are hopefully in the next week or so going to have the results of a clinical trial where we artificially induce on the skin some chemical dermatitis, and we're going to be comparing that, the recovery of that skin, to placebos and also to positive controls like hydrocortisone, because we very well might just see that this could be a new steroid-sparing agent for these skin conditions. So we're doing that with all the PEITC stuff. With regards to urease inhibition, we've been doing some really interesting work with Bath University. Bath University have got a computer model of the crystalline Helicobacter pylori urease. They can move around molecules, what happens, and to see how far. We sent of the urease and fed back to us that the inhibitors all bind sites to the same. Some of them are reversible binding at the active sites, some of them are irreversible binding, and some of them are covalently binding at sites away from the active site, but which changes the conformational structure site to basically inactivate the enzyme. This is really good news for us because it means we've got lots of different mechanisms of action at one enzyme. And we know from the literature that the urease enzyme is a nickel metalloenzyme, which is relatively well preserved across nature. It doesn't change. An H. pylori urease enzyme is going to be very similar to a Proteus urease enzyme, which is going to be in the urinary system, which is going to be similar to the Jack bean urease enzyme from a plant that we tested before. So we believe, and the statistical modeling suggests, that we will have fantastic inhibition at the urease site of a Helicobacter pylori. The reason this is a good target to go for is, of course, the Helicobacter pylori urease is extracellular. We don't have to worry about getting the molecules into the cell wall of things like Proteus. Largely, about 80% of the urease on H. pylori is extracellular. So if we looked at that as our first oral mechanism of action, Helicobacter pylori is a very good bug for us to study. So it damages your stomach. About 10% of people who are colonized will develop an ulcer. It causes inflammation and gastritis and horrible indigestion type of symptoms. And it's also very strong for stomach cancer. So in the UK, about 40% of people are infected with gastric cancer, with Helicobacter pylori. And gastric cancer is the 12th most prevalent cancer, with the ones that we will all know as being most common: breast, prostate, lung, bowel being near the top. If you take Korea, Colombia, and Japan, who have 50% plus, sometimes as high as 80% infection rates of Helicobacter pylori, their stomach cancer rate is, in all those three countries, is the most common cancer. So this is the data for Korea. So stomach cancer is above lung cancer in men, and it's above colorectal cancer in men. And it comes up from 2008 onwards. It was the second or third most common cancer in women. Now, obviously, we know from what we talk about in epigenetics, there may well be a genetic contribution to that population which makes them more susceptible. But we also have to remember that there is this environmental factor with the H. pylori. So we wonder where we go a little bit in the sky to fluoride in water for people's teeth across the UK, and they're doing very similar things now with to find breads and rice to make things more nutritionally complete. Couldn't we be doing something with watercress on a population level to reduce, by the way of natural plant-derived urease inhibitors, the rates of gastric cancers in countries that are effective and which maybe don't have access to watercress, which doesn't grow in every country? So this is something that we are working with the University of Bath. We're discussing with Public Health England Colindale, who are hopefully going to supply us with various Helicobacter pylori strains that we're going to find in this country and different countries, and we're going to be doing the tests of that. And if we demonstrate this, it means we have made a new antibiotic. MHRA may not see it that way because they don't think plants can be antibiotics, but we'll come on to that a little bit later. So, assessing where we are with urease inhibition and PEITC work now, we're starting to get discussions with MHRA. They don't feel that a plant can ever be a medicine. And to make health claims with plants are very difficult because obviously as you go from season to season and country to country. You get natural variation, and of course you get that with harvesting and things as well. So we have just been having some discussions with people who do vertical farming and hydroponics, who might be able to breed genetically identical strains of watercress from the Watercress company, which we have manipulated to give a higher yield, and we might be able to grow them vertically in vertical farms hydroponically, which might actually mean that it's a regulated enough process that we can get a drug classification on this, or we can keep it as a nutraceutical food supplement. Because we're doing an extract, we're currently going through the Food Standards Agency and Novel Foods application. If we were just powdering watercress, we wouldn't need to do that. But because we're extracting and concentrating, we need to get sign off that there's nothing toxic in there. And at the minute, we're setting up a food grade facility, likely going to be in one of the biorefineries, either Beacon Biorefinery at Aberystwyth or in York. We're setting up some quality control. And we have got research groups waiting in the wings who we've been having lots of good discussions with, including the Cyprus School of Molecular Medicine, a chap called Professor Panagiotis, who is a fantastic chap who's the most prominent researcher in PEITC and cancer today. So once we've got this up and running and we've got our license for food grade, we can then start doing the oral trials, and we're hoping that's going to be coming up very soon. So the final bit in this process, we've obviously made our extract, but we've also got these curds, which are quite interesting. So this is that protein which curdled out. When we did a bit of cheese making, we removed these curds. And actually, the story does get really good with this because it's a very, very good plant protein. So when we powder it down, it goes from about 20% of the starting weight as a putty, which is that picture on the left, down to about 5% of the starting weight of watercress. When we compared it to other plant proteins, it more resembles an animal protein in its essential amino acid profile. So I've highlighted the watercress one there. At the bottom of the first, halfway down the first column, you'll see 43.9% of the total amino acids in watercress are essential amino acids. Now, this means that they're amino acids which you can't cycle and make in your gut. You have to take them on exogenously, so you have to ingest them. And typically that's higher in animal proteins. So your whey, your milk, and your casein, as you can see on there, they're on their 40s. The plant proteins typically are in their 30s. Now, the reason this is great for us is getting essential amino acids into the diet can be difficult for people who have a plant-based diet, such as vegans and vegetarians. So this might be a more preferable plant protein to those that are already on the market. The other thing, of course, is it's very, very good for you. So it's got about a third of its fiber. I've just put all this information on. This is what we had done at Camden BRI. It's a very, very good protein source. So you'll see what I've highlighted here, a key bit. The protein content is 39.4 grams per 100 grams. If you look on the left, this is the right in the bottom left, the protein content per 100 grams of some other animal meats: chicken breast 32, beef steak 29, lamb chop 31. This watercress curd has got a higher protein content than all of these different animal meats. So it could really be a very useful byproduct for us, full of fiber, and full of other useful vitamins and minerals, which is why it's caught the attention of the University of Cambridge. So they have got something called the Enterprise Tech Programme, run by the Judge Business School. So I've now got a team of 5 very bright PhD researchers, all from different backgrounds, from molecular genetics through to engineering, maths and history. And to give them experience in the business, they are going to be looking at the different avenues where we can use this protein fiber byproduct to maximize it. So they've been telling me already they're looking at vegans because of obviously the essential amino acids. They're looking at racehorses because they need essential amino acids in to improve their performance. And something else which is now very topical, if anyone's can pick up in the bottom right, they are Scottish salmon farms. So a big problem at the minute is typically it's animal protein which is put into those. It leaches out of the cages and it causes environmental damage because of the ammonia. Because we have an essential amino acid profile more resembling animal protein, this could replace the need for an animal feed to go in there and then also protect the environment. So other urease inhibiting work we're doing at the minute, We are hopefully going to be doing a trial with Watercress Research into the cows, because again, if we can stop the urea to ammonia conversion in the gut, then the urea gets cycled into other useful things, and they improve their yield. We are hoping to do some work with grasses. So those two pictures in the bottom right from my mum's garden, we put a 10% dilution of watercress extract on the left side of her garden. The right side was just treated with water. And I think you'll agree that that grass is looking much greener and much fresher. And we did a little separate pot on the right. That's likely driven by the high nitrate content as well as the urease inhibition. And we're working with lots of other companies on that as well. Some other left field work that we're doing of interest, because watercress is very high in nitrate, we can inoculate it with bacteria which have nitrate reductase enzymes. So these are bacteria which you will commonly find in your gut and in your mouth. And the high nitrate we can convert to nitrite. That will be a novel meat curing agent. So nitrites are used in bacon and sausages as a novel meat cure, and we're very shortly going to be doing a trial to see if we can do that in a more natural way, because of the association with the saltpeter with colorectal cancer and other health benefits. And we're also looking to see if we can cure athlete's foot, because we can use the nitrate to make other reactive nitrogen species which are activated by sweat, and fungus don't like nitric oxide. So there's some other bits that we're doing. Come towards the end now. We're hoping to have our commercial food grade facility up and running by April, with a license agreement for continence care, which is in its final stages of discussion. We're just waiting for the clinical trial to come through with that, and we're working with a very big supplier in the UK. We're going through a novel food application. We submitted our process and composition patent based on the mixing and the curdling and the separation and how we maximize that PEITC. We submitted that in December 2020. We're looking obviously with the protein and extract product streams through the University of Cambridge. They're due to present their work to us next month. We're hopefully going to move into the food and drink market. And when we're up and running, we're going to be actively seeking collaborators for all these different projects, because quite frankly, we are not going to be able to keep up with all the work that we want to do. So we're really going to be seeking people who either want to collaborate and take on the research with us, or help us with funding, or get involved however we can. And please do contact me on my email address below if you want to do that. So things that we talked about, just to wrap it up, because I'm sure there'll be a few questions. We talked about PEITC and inflammation and epigenetic regulation for cancers. We think we may well have something which could be a useful adjunct in cancer, and we are desperate to get through our food sign-off so that we can test this in trials. We talked about urease inhibition as a novel antibiotic for Helicobacter pylori, maybe also for the treatment of hepatic encephalopathy and liver cirrhosis and these urinary tract infections. We found a new bacteria which has some very cool properties which we are looking to work on in the next 6 months. We're doing some work with the Watercress company on the plant science to see how we can change environmental factors and breed in other factors to maximize the yield of our target molecules that we want. Guest genetics, lab skin, and of course the biosystems one that I showed you, which I haven't had a chance to put on here. These novel drug development platforms are absolutely the future. So we've, using lab skin, managed to get the data which would have taken us months, if not years, to get through clinical trials. They are absolutely the future. The protein fiber complex is moving forward. And I think finally, it's just to say, it might all sound far-fetched, but remember, aspirin came from the bark of a willow tree, digoxin came from foxglove, morphine came from poppies, penicillin was made on a windowsill, and even the chemotherapy agent paclitaxel came from the leaf of a Madagascan starflower. And don't forget where it all started, our little cherub. And very quickly, we need to say thank you to Torbay Medical Research Fund. Without them, this would never have happened. They absolutely took a punt on this research 3 times, not asking for anything in return. We are always indebted to them for that. I think it's a fantastic charity. So please do have a look at their website. And you can go through torquaymedsoc.com to go through the charity. I'm now the president now. I'm delighted to be there. And I hope you're all keeping safe and getting vaccinated. And thank you very much for listening. I'm going to try and stop this broadcasting now. There we go. So if anyone has any questions, then be delighted to.
Well, thank you. Yeah, thank you very much, Kyle. I mean, cancer cure, eczema treatment, antibiotics, racehorse feeds, vegan food supplements. Does it work as a boat anti-foul? I'd be in heaven if that was true as well. Having been talking to one of the guys doing the first ever research on aspirin and heart disease in about 1968, when I was still a teenager and I had no idea of the statistics of it, neither did he. It's very interesting to hear this at a very early stage, and we look forward to where this is going to go. So if you'd like to put up your hands for any questions, I think I'll start by picking up any questions on my screen. For those of you who've got your cameras off, I suppose you could either put your cameras on or send a WhatsApp to. No, actually, you can't do that. Anyway, if you use the chat one if you haven't got your screen. Right, Dr. Alam, I saw your hand go up.
Yes. Thanks for a nice talk. But I'm just thinking, because we usually have watercress in our sandwiches. My question is, should we continue eating the watercress in the sandwiches or not? Will it cause any harm?
No, absolutely. The watercress is a fantastically nutritious plant. In fact, it's one of the most nutritionally dense plants there is, and it's fantastically good for you. We just have to be careful because we're trying to purposefully stress the plant into doing something it doesn't want to do, which I guess you could argue, is a bit like saying you might eat an orange. Would you eat a rotten orange, or would you eat one that had gone off? Probably not. That's had chemical changes to it. It's still an orange. Watercress is fantastically nutritious, and we've got a great working relationship with the Watercress company. So absolutely eat watercress.
Thank you. Right, I see Barbara Bray, you've got your hand up. What's your question, please?
I do speak to Carl quite often and I still have questions. Carl, going back to what you said about the production methods, obviously it's great if you're able to mop up surplus watercress that's growing in the field, but you clearly say that we do need consistency in the production to be able to replicate the kind of levels of the different chemicals that you need. So if you're going to go to a vertical farming system, how is that going to work? You're really going to have to create a whole new way of production just for making the chemicals that you need to make the topical application and so on.
Yeah, so I think, so your microphone was a little bit cracky there, but I think I got the gist of it. So you were asking about when I mentioned about vertical farming, how that would work maybe on a bigger scale. So at the minute, we're in a fantastic position because the Watercress company is overproducing watercress because it has to meet its supply contracts with Tesco and Waitrose and these people in case one of the fields gets knocked out by E. coli, adverse climate. Now, the shelf life, or the time from cutting to it going off effectively, might be about 9 days, where we can take the surplus, when there is surplus, and change it to something which has got a shelf life of many, many months. Now, I think for the vast majority of things we want to do, that's going to work fantastically. The reason we have it, the reason the hydroponics and things are interesting in terms of sustainable farming is that might be where we get into drug territory. And my feeling is that's going to be on much, much smaller volumes than what we're currently doing now. I don't necessarily want to go down that route because I quite like this being a plant-based thing and farming, and I like the story. But certainly, if we get good enough results and we think we can improve the characteristics of our extract, and MHRA come back to us and say, for this purpose, we will license it if it's made in this controlled way, I think it's got to be given consideration. But for now, we'll use the surplus, and that's where this, it's a great story of a farmer. I always say farmer, A-R-M-E-R, going to farmer, P-H-R-A, A-R-M-A, farmer to farmer. It's quite a nice story.
Carl, and I'll be in touch later because I need to get some of the contacts that you've got for some of my other clients as well. So thank you.
Cheers, Barbara.
Right, Joe Ross, I see you've got your hand up. Would you like to ask your question, please?
Sure. Yeah. Hi, Kyle.
Hi, Joe.
Great talk. Thank you very much. Really good to hear the whole spectrum of what it is you. I guess one of my questions was around. I think you mentioned very briefly different watercress variety. So I wondered how you've done to sort of look across the different varieties of watercress, and whether you've done much in terms of looking at watercress plant breeding.
So at the minute,
particular trait.
At the minute, we haven't, purely because we don't fully understand how it changes from country to country and season to season, because we've only had the company set up in the last year, really. So we need to get through a few seasons to understand the differences. We know that the Spanish watercress that we get usually around the winter time, the Spanish watercress has a better urease inhibitory profile than the Floridian watercress and the UK watercress. We don't know why. But also, if we take the wintered watercress from the UK, which is a bit thicker and a bit chubbier, they don't sell it because it doesn't look very nice. That has got a better urease inhibiting profile as well. So we think the plants are upregulating their urease inhibitors when they're in harsher environments, because they need to hold on to the nitrogen to assimilate the protein. And it's more difficult in those conditions. So in time, you're absolutely right. The Watercress company have got a bank of different species of watercress with all different phenotypes. So some are dark leaf, some are taller, some flower, some don't. We're absolutely convinced in there are going to be other molecules that we don't know about and other combinations we don't know about. Because, you know, if we're looking at the extracellular urease of a Helicobacter pylori, that's got to survive in the stomach acid. That might need a different urease inhibiting and biochemical profile to something which is going to be effective topically on the skin. So what we might end up saying is actually species 4C needs to be harvested in Spain at this time. That is going to be our Napuash crop. And this watercress is going to be our H. pylori crop. But actually what we need to do is breed it with this one, because that will then give us these favorable characteristics. So there is a myriad of plant science that we need to do. And that's one of the things we're looking to collaborate in. What can we breed in? What can we breed out?
Okay, talk about that.
So I know you do that.
Right, at the moment, I can't see any hands up. Would you wave at me enthusiastically if you are dying to ask a question? I'm sure there are many.
There was a couple of questions on the chat. So Tom was one, I think.
Tom?
Let me see if I can read out this question.
Right.
Where is it? Sorry, just looking for it on the chat.
So have you investigated the anabolic potential of the watercress protein in humans?
You got it.
So that's an interesting one. So one of the proteins which might be present is something called rubisco, which I've not had time to understand, because of course one of the big problems, it's not just about how much protein you have in something, it's what is the bioavailability of that protein. So I think it's fair to say for some meats and things, while they might have a lot of protein, if you can't actually absorb it and get it in a useful form, it's not that useful. So, you know, this is where we haven't had a chance yet to do that bit of work. What we really need to do is talk to the nutritionists, the dietitians, for them to look at this amino acid profile that we've got, both in the natural form as it's in the watercress powdered down, but then also in this denatured form, and try and see which is best. So we don't know that yet. It's a great question. And if we could set up trials to look at how we could change the anabolic capacity of the protein, that would be great, because of course we can use urease inhibition to improve the efficiency of what is hopefully already a very good protein. So we can have a double effect. Someone's mentioned a clarification point: if we chew watercress for 2 hours, do we reap the benefits of anti-cancer and anti-inflammation without any harmful adverse effects? Don't know. Need to do a trial. You probably get a sore jaw. It's impossible to say what would happen there.
There's a question from Marina Morgan as well.
Mm.
Do you want to ask it directly, Marina?
Oh, hi, that was absolutely fabulous, Carl. Thank you. Yeah, that's fabulous to find a new bacterium as well. That was really, really fascinating. Very simple question. Apart from the parasitic things you get from the wild watercress, you know, the Fasciola fascica and stuff like that, is there an actual content or nutritional difference and scientific chemical difference between the wild watercress and the cultivated watercress? Because presumably your culture methods will affect what you put into them, will affect what grows. So
there will, yeah. So the nutritional, I mean, the nutritional profile of the watercress you get in the bags is very good. We haven't done a controlled study with the wild watercress to know what that difference in the nutritional profile is. Again, this was all coming back to that plant medicine side of things, and what are the different species of watercress and how is it going to differ. What we do know is if we harvest the watercress on a morning compared to on a night, it can make huge differences in terms of nitrate level, in terms of all sorts of other things. It can make a huge difference. So the thing that we're struggling with is we're obviously dealing with a plant which is grown seasonally and has those variations. We're then having to deal with the difference in when it's harvested, whether it was raining, whether it was cloudy, whether it was sunny. If it's sunny, you have a very different profile to if it's not. And again, it's all these different stress hormones, and whether it's trying to grow and respire in good conditions or whether it's trying to hunker down over the winter changes massively. And this might be where the hydroponics and the vertical growing comes into its own, because if we can eliminate that environmental and seasonal change, we might be able to just start unpicking, well, what happens if we pick it with light? What happens if we pick it in the dark? And just isolate that change and then start building up our knowledge base. And then when we know how that reacts, we can then subtract that from the seasonal changes that we see and predict things more in the future. But the fact that we found a new bacteria in the UK, again, makes us just wonder. So I'm aware of your microbiology background. I'll discuss in confidence with you what that one is for your interest. It's it's fascinating, and some of the characteristics of that bacteria do lend itself to other things, such as your meat cures and other bits and pieces like that. And it perfectly describes why there might be this symbiotic relationship, which if we can just start unpicking it and stressing that relationship, we can then get the good chemicals out, which are having the benefit to humans. So it'd be great to chat to you more about that as well.
thank you. I think you might have another first actually, because I can't think of another microbe that has a symbiotic relationship with a plant, apart from the ones that only in rock bolts and things like that damage the plant. So I think that's amazing. Thank you.
Carl, there was a comment from Bianca from SWP CRN. Not so much a question, but might be worth introducing her to make contact and join the discussion.
Fantastic. Yeah, love to.
Yeah, Carl, we've obviously communicated about this event, but yeah, if there is trials that you want support with, we can support.
Thank you.
Good. I think George Wrighton has asked a question on the chat. Do you want to speak to that, George? If you'll need to unmute yourself.
So George, I've got the question here. So George has asked, say a bit about your innovation journey, what you've learned, where you found support to tackle patents and alongside your clinical work. So George is a fellow NHS England clinical entrepreneur like me, and I think we both had a very difficult journey trying to do this alongside clinical work. One of the reasons that I chose general practice as a specialty is it was more accepted to be a part-time GP and have other interests. And I think one of the key things for me is encouraging clinicians with these bright ideas to go ahead and pursue it. But coming back to Torbay Medical Research Fund, I could never have done this without them. There is no way I would have sat down to do an Innovate UK bid for this. It wouldn't have been accepted. It was far too high risk. I wouldn't have known how to write something that long, and I wouldn't have wanted to wait a year to do it. The Torbay Medical Research Fund approach, it was fantastic in taking a punt. So without them, I would have been very lost. And I think George asked about innovating and being an entrepreneur and things like that. And I think we're just sort of born with it. I think I like to quote people, and Elon Musk was asked if you had any words of encouragement for an entrepreneur, what would those words of encouragement be? And his answer was, if you need words of encouragement, don't be an entrepreneur. And I think that pretty much sums it up, because it doesn't matter what people do. You know, we thought this is going to fail many times, but we just keep going along with it. And now we're in quite an exciting stage where it feels like there's more chance something's going to work than not. There's sort of light at the end of the tunnel, and the results that we're getting are very good.
Good. Is there anybody else with a question that they'd like to ask Kyle? What's that from Helen? Helen, I didn't. What?
So Health Education England have trialled less than full-time working beyond the usual health and childcare reasons. Emergency department and obstetrics and gynecology with the trial sites. This is being rolled out to other specialties. New chances for entrepreneurs to also work clinically, which is fantastic. It's exactly what we need.
Yes, they've realised that to maintain morale, for trainees to have the opportunities that they need, that this will be a new way of working. So it's certainly within the School of Medicine from 2021, we'll be doing small trials. And then from 2022, there'll be a whole new category. So someone like yourself, Kyle, could opt for a 0.8 to 0.6 contract and research 2 days of the week. Don't tell our rota coordinators, but other than that, it's great news, very positive.
Good. Well, thank you. Well, I think that's probably the questions running out, and I'm sure many of us will think of questions we wish we'd asked afterwards. But I'm now going to just ask Lorraine to propose the traditional vote of thanks. And over to you, Lorraine, please.
Thank you, Norman. Good evening, everyone. My name is Lorraine Roberts. I'm a retired GP, and it gives me great pleasure to propose the vote of thanks for tonight's inspiring presentation. But first of all, I want to thank you all for attending tonight's Zoom Torquay District and Medical Society meeting. Over 90 registered for this evening, so it's quite incredible. And speaking as the Honourable Treasurer of Torquay District Medical Society, I do hope some of you feel inspired to join us, which you can do via our website, torquaymedsoc.com, for the princely sum of £10 a year. I also want to thank Di Jones, our website manager, for setting up and orchestrating tonight's Zoom meeting, and Norman Doidge for chairing the meeting and coordinating your questions. Quite a challenge, and I think it's gone very well, so thank you both. It's nearly 4 years ago that I attended the Torquay District Medical Society meeting at the Imperial Hotel when Kyle presented his research into watercress, talking about its medicinal properties, potential applications, and he also gave us samples of the excellent beer that had been produced. So we were very impressed. There seemed to be endless possibilities, from the bedpan that could predict infection, nappies that could prevent nappy rash, dressings that could prevent fungal infections. And at that stage, the bedpan was already being used in some hospitals. Kyle was a worthy winner of the Torquay District Medical Society £400 annual prize for best research innovation. And the audience was absolutely spellbound. We couldn't believe that watercress could be so exciting. Who'd have ever thought it? It was just amazing. And for me personally, it made me realise that research didn't have to be dull, doctors didn't have to be dull, and if they wanted to do research, then why shouldn't they? Why shouldn't they have curricula that allow them time out from clinical work? So it's quite a light bulb moment. We were impressed by Kyle's energy and enthusiasm, and it was obvious that evening that he was already on a journey into the world of innovation, design, and patents. So it was a great anticipation that I attended tonight, and we certainly haven't been disappointed. I think you'll all agree with me about that. The whole story seems to have exploded. I don't know how there can be 1,000 a day for you, Carl. I can't understand how you can have all those interesting networks that you're working with, and the university departments, the research departments, skin, cancer, by antibiotics. It's just out of this world, and I'm sure you are very excited. I don't know. Yes, well done you. And as you say, this isn't something you learn. This is something that's inbuilt in you. You can't help it. So will you please join me in thanking Kyle in the normal way, although we probably won't be able to hear you. Thank you, Kyle. Thank you, everybody.
Yeah, bro.
I'll just hand you back to Norman. Sorry.
Thank you, Lorraine, for that. Again, I'd like to echo Lorraine's thoughts of thank you to Di and to Jackie for setting this up, and for everybody who's put effort into these meetings. We're going to have another Zoom meeting in a month's time on 25th of March. And this time we're going to have something which is topical, I think will be a little bit different to what we read in the papers. We're going to hear from those who've been directly involved caring for patients with COVID here in Torbay. And Helen Waters is going to coordinate that meeting for us. And we'll have a number of different people talking about their experiences, which I understand will be doctors, nurses. I believe there's going to be some patients and probably other groups as well who've had a major involvement in this Herculean effort, which we all fondly think might be beginning to wind down, but I think we have to be careful on assuming that. So we look forward to that, and I think that will be a very popular meeting. An invitation to sign up for that meeting will go out shortly, and that will allow us then to send you the link. So it's a final thank you to Kyle, who'll be back in his normal seat, I hope, as chair next month. And so it's now just to say it's good night from him, and it's good night from me. Good night, everybody.
Good night.
Thank you for all for coming.
Okay, we're going to go now.
Good.
Thanks, Norman. Thanks, everybody. Have a good evening.
Thanks, Di.
Thank you.